Hey guys, I tried doing this live and I felt like there was too much noise, I don't know, I felt like it would be too annoying to watch. So I figured that it would be better to just record these and then y'all could ask me questions. So what we're doing today is new. I mean, you probably did a tiny bit of this last year in Algebra 2, but it's not a whole lot. Like taught in Algebra 2, only just a little bit of it. So for a lot of y'all, this is gonna be pretty new. It's not really that hard. It looks like it's going to be terrible. So you just have to give it a minute and it's really not that bad. So basically a logarithm is an exponent. Okay. So if you know your rules we just did exponents in the last little section. So when you multiply two things with exponents on them together, say like this, if you had x squared times x cubed, you get x to the fifth. So when you multiply exponents, you add. So the same thing happens with logs. Since logarithms are exponents, when you multiply two things together behind a log, multiplication turns into addition, just like exponents turn into addition, okay? And it can either be with a logarithm, or it can be with ln, which is the natural log. And we'll get more into what the difference in those is a little bit later, but just realize whether you see the word log or whether you see ln, it's the same thing, okay? Anytime you're multiplying here, you can separate them out by adding them. What we're doing is expanding logs out because they're gonna be easier to work with depending on which form they're in, okay? So the same thing happens whenever you have something like, say, x to the fifth divided by x to the third. What do you do with exponents right here? You subtract. So you end up with x squared, all right? So exponent properties say to divide exponents, you subtract. To divide logs right here, this is a division, you subtract. So logarithms follow the rules of exponents. And again, this is just the same thing. Log or ln both mean logarithms, okay? And then what happens in a power to a power? If you had x cubed squared, remember that turns into x to the sixth. So you multiply. Whenever you have log to a power, you multiply by the exponent. I always like to say exponents jump to the front. So if you have x to the y jumps to the front right here, okay? I think whenever you look down here at the examples, it's gonna make more sense, okay? So coming down here. So for this first one, if the directions say to expand the logarithm, what you wanna do is you have to write the word log in front of every single one of these parts. It might be helpful to find all the parts. So you've got a 5, you've got an x squared, and you've got a y. There's 3 parts, which means you're gonna need the word log 3 times. So log of 5 is the first one. Because this is multiplying, you add. And then the next one, leave a little spot because that's log of x squared. But the property for squared says jump to the front. So exponents jump to the front of the word log. And we're still multiplying, so we have to add another log of the last one. So take a second and look at that. If you want to expand this logarithm, it's log of 5 plus log of x squared, but instead of putting squared here, it jumps to the front, and then a plus log of y. Okay. All right, so the next one, remember ln is just natural log, but we're still gonna follow the same rules for logs. So we're gonna start, let's go with, before we can do anything, 3x minus 5, remember what we learned last time? 3x minus 5 with the square root is the same thing as 3x minus 5 to the 1/2. Logs work better with exponents than square roots. So if you have a square root in your problem, turn it into a fraction exponent. All right, and then it's still over 7. So what we've got to do, we're going to write this as ln. So we have 2 parts here. We have a 3x minus 5 part, and we have a 7 part. The 3x minus 5 stays together. You don't separate adding and subtracting. They're always in a parentheses together. So that's 3x minus 5. But don't write the 1/2 right here. Anytime you're about to write an exponent, it jumps out here to the front. So it's 1/2 ln of 3x minus 5. Okay. Remember, multiplication turns into addition. Division turns into subtraction. Every time you have a new term, you have to write the word log or ln in front of it. So here I had 2 terms. That means I have 2 ln's, and I need to subtract them because it's a division problem. Okay? All right, this one's a little bit more complicated. And by the way, for right now, this little base number doesn't matter. You just leave it there with the word log. Okay? All right, so I have a term up here and a term there. That means I'm going to have the word log written down twice. So I start with log, and since there's a little number there, you put a number there. And I need to write x squared. So I put down x, don't put the squared here, jump to the front. So that's how you write log base 3 of x squared, the 2 jumps to the front. It's a division problem, so you're going to subtract. And this one is, I'm leaving a space because I see an exponent. So I have log of x minus 1. Don't put the cubed right here. The cube jumps to the front. Okay? And I promise there's a point to all this, but we have to learn how to separate them, expand them, and then we're going to learn how to condense them, and then we'll get into what you do with them. Okay? All right. So for this last one, remember the first thing you want to do whenever you see a root is rewrite it. So the square root, remember, is to the 1/2 power. So you see 2 parts, 1, 2, right? Because we have an 8 under this. So I've got to write an ln of the top, 4x plus 1, but the 1/2 jumps to the front. Because it's division problem, I put minus. I have to write ln again of 8. All right? So look through that. If you're confused, you might want to rewind right now and look at a couple of them. The main thing is, if it's a multiplication problem, you separate it with addition. If it's a division problem, you separate it with subtraction, just like exponents. Okay? All right, let's go to the next. All right, so I don't know why there's not room here. I think they're supposed to be on the other page, but let's go with this. All right, so this is just practice. This time our example starts off, do you see how it's already separated? It's already written out in expanded form. You see log in here more than once. So now we're going to go backwards. We're going to condense the log. So on the other page, we were expanding it out, and now we're condensing it down. So anytime it's condensing, so I'm going to do A first, okay? So anytime you're condensing a log, you can only write log 1 time. So let's say on your math lab, you're trying to pick from multiple choice which one's correct. If they ever write log twice and you're trying to condense it down, then you know it's not right. It's got to be written down once, okay? So this time I'm going to have the word log. I know that. So what do you think log of x with the 1/2 in the front? Anytime it's in the front, that means it must have started off as an exponent. So what I'm doing here is trying to go backwards. So that means this must have been log of x to the 1/2. So instead of writing that, I know x to the 1/2 power is really square root of x. If that's confusing, you could always write it like this first. And it's not necessarily wrong to leave x to the 1/2 power right there. It's probably better with the root, but it's okay to leave it as a fraction. Now, the reason I put a fraction bar right here is because that's a minus sign. If it had been a plus sign, I would have multiplied, but a minus means you're dividing. So I know I've got an x plus 1 on the bottom, and that 3 in the front must have come from an exponent. So I'm undoing what we did on the last page. So now if I were to separate this out, you see you're going to have log of this minus log of that. Exponents jump to the front. Okay, let's come over here and do B. All right, so it's an ln. That means nothing different other than instead of writing the word log, I'm going to write ln. So I know I'm going to have an ln. I see an x plus 2 with the 2 in the front. That means that there used to be a squared right here. So I'm going to write that as x plus 2 squared. So that takes care of this first part right here. Whenever it's a plus, you want to multiply. So now I'm going to multiply that by x. You can either put the x here, or you could put the x right here in front of the parentheses. It doesn't matter, but it's a good idea to either put a bracket or a big parentheses around all of that, because all of this is behind this ln, okay? Remember, these are multiplied together. That's why the original had a plus sign. Okay, so we're going backwards. All right, I'm gonna switch because I'm gonna do letter C right here below. All right, so this time, first off, you see a plus, so you know you're gonna be multiplying. Write down the word log one time only. So that's x to the 1/3 power. Remember, this 1/3 must have been the x on the exponent on the x. So if it's x to the 1/3 power, that's got to have been the cube root of x, because that was really x to the 1/3. And so a 1/3 exponent means cube root, okay? Because this is a plus, that means we're going to multiply by this one. You don't write log again. You're going to multiply by x minus 3. That 5, remember, since it's in the front, means it had to have been the exponent, okay? And then all of this right here goes with that one log, so put it in parentheses, and that's a little more accurate, okay? All right. So again, the plus made this into a times problem. You write the word log down one time. Numbers in the front jump back up and become the exponents. Okay. All right, for letter D. All right, so this one, you want to work out this inside part first. So what we're going to do with that is we're going to make this ln. And you notice a subtraction right here, which means we need to divide. So it's ln of x over x minus 2. All right. And if that entire thing, all of this right here is the 1/5 power, you don't put it around the ln. What you're going to do, it means that there was a 1/5 on this one and a 1/5 on that one. So what you can do is just put the 1/5. Sorry, I shouldn't have written 1/5. That's to the 1/5 power. So this is just the 5th root. Sorry, that's a 5, not a 1/5. Because it's all of this to the 1/5 power. So when you have something to the 1/5 power, that's the same thing as the 5th root. So this is ln of the 5th root of that entire thing. And again, this is a fraction because there was a minus in the middle. All right, so plus goes with multiplying, minus goes with dividing, okay, just like in exponent rules, okay? All right, now we have one really long one here. We can do this, all right? So first off, remember, the directions on this said condense, not expand. It's already expanded. If you see more than one log in the problem, it's already an expanded form. So we're going to condense it down. So first off, notice right there you have a minus, which means this is going to be a fraction. So it's going to be log, and there's just a little b there. It doesn't matter what it is. You just write it down. I know it's a fraction bar. So you put x squared minus 9 on top, and you put this on the bottom. X squared plus 7x plus 12. Now it's going to be beneficial later on when we're solving equations if you simplify these things. This is good factoring practice too. So this is the same thing. We can write that as x plus 3, x minus 3. Y'all recognize that as a difference of squares? And the bottom multiplies to make 12, adds to make 7. So x plus 4, x plus 3. So those cancel. So the simplest form of this log is x minus 3 over x plus 4. The thing I see most people mess up on this is they want to write log on the top divided by log on the bottom. Anytime you're condensing logs, you can never have more than one log in the problem, okay? Anytime you're expanding logs, I'm going to go back to this for just a second. If you're expanding logs, however many parts you have right here, however many terms there are in here, that's how many times you have to write the word log down. So we need to be able to go from here to expanded form, or from expanded form to condensed form, okay? This looks like expanded, and this looks really condensed, all right? All right, and then this last thing that goes with this is we need to be able to change an exponential expression into a logarithmic expression, okay? So what we're gonna do is we're gonna see how this compares to this, all right? The way I remember it, the easiest way for me, if I know this form and I wanna get to here, this right here, the 5 is called the base and the 2 is called the exponent, right? So I'm gonna say, when I write it as a log, you write the word log down, whatever base is the base over here becomes the little base of the log, okay? The 25 goes here. The exponent right here becomes the answer to the log, okay? So 5 squared equals 25. If I want to write this in logarithmic form, the 5 is the base here. It becomes the little base over here. The answer goes here. The exponent goes there. All right? The exponent becomes the equal side of the log. Remember that. All right, so let's do this one. The 10 is the base because it's 10 to the 3rd power. So the 10 becomes the base of the log. The 1,000 goes next, equals the 3. Okay? This one, log, there's their base, so the 2 goes right here. The answer goes here. The -4 goes over there. Okay? All right, so let's do this one. They're trying to be tricky here. They're putting it backwards. Which one of these numbers is the base? Since the 8 is the base, when I write it in logarithmic form, the 8 is the little base. The answer goes here, and it equals the exponent. You could think of it like this. You put the base down, log of the base, the answer equals the exponent. Okay? This one, you write the word log down. So what's the base that you see over here? It's a 2. So that becomes your little base of the log. You would read this as log base 2. So base 2. The answer is 32 when the exponent is 5. Base, answer, exponent. All right, this one, same thing. Log 10 is your base of 0.0001 equals -4. Okay, and these are true statements. Okay, if I did this and I said, does 5 squared equal 25? That should work out, and it does. You're going to need to be able to convert an exponential equation or expression into a log. And you need to be able to take a log and go backwards to this. So let's look at that for a second. If I gave you this problem right here, let's look at this one. And I said, rewrite this log as an exponent. You start with the base and you say 2 to the 5th equals 32. I always do this. I'm going to write this over here larger so you can see this. I call this swooping. So when you have a logarithmic expression over here and you want to turn it back into an exponential, you swoop it. You start with this and you go like this. See how that turns into like an exponent? So if you have a log and you want to get it to an exponent, you do this little E pattern. So you start with the 2 to the 5th equals 32. Okay? Because eventually you're going to have an X in one of these places and you're going to have to solve it. So if I gave you this, log base 2 of 32 equals X, you would solve that by swooping. Your swoop means to do this. So you say that means 2 to the X power equals 32. And then you have to solve this problem. 2 to the what power is 32? 2 times 2 times 2 times 2 times 2. So X would equal 5. So that's what we're going to do next, is go from setting them up to solving them. In these problems, there was no X's. It's just learning how to practice going back and forth. But eventually we're going to put an X in one of these three places and you're going to have to solve the problem. Okay. So this covers the properties of logs. One thing I want to show you, if you have something like this, if there's a plus sign already in the middle with one log, you can't do anything else to that. You can split up multiplication of logs. You can split up division of logs, but you can't split up addition or subtraction. All right. I don't think you're going to see that in your math lab, but I wanted to point that out just to be clear. All right. At this point, after you've seen this video, you should be able to do some of your math lab problems. But if you ever have to solve, you're probably not quite ready for that. But I'm going to get the other videos posted pretty quickly. All right. Thank y'all. Let me know if you have questions.